Good morning, friends and dear students. I am here again for my course Aircraft Systems. Today I am going to discuss about flight control actuation system. As of now, I have done the different types of flight control, how the flight controls are working. These all things are done, but how these things are moved. Actuation means how this motion of the flight control, like elevator, aileron and the rudder, how these things are moving. That is the objective of this our today's topic. As you know that I am Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India, and my today's topics of these lectures are principles of flight control system, types of flight control system and actuation systems. These things I am going to discuss. However, some parts I have already covered in my previous lectures about the flight control and all. Still, because once we have to study about the actuation system, we should go what we have to actuate. So, I want to say that I want to actuate the flight controls. So, what are the flight control? So, if you see this aircraft here, there are three basic parameters on which aircraft fly. We can divide this thing into the three axes. One is the axis which is passing from tail to the nose or nose to the tail, that is the x-axis, or this is also called the roll axis, because the rolling motion will happen on this x-axis. Another axis which is passing from wingtip to wingtip via the center of gravity, and here the pitching will take place. This is called pitching. So pitching motion will take place, and this pitching will take place from the lateral axis. This is called the longitudinal axis or the roll axis. This is called the pitching axis or the lateral axis. So this pitching means nose up or down. It is called pitch down and this is called pitch up. So this pitch up and pitch down will happen on the lateral axis or the y-axis, or whatever you can say. And this yawing motion, if you see like this, yawing motion is from this vertical axis. This nose moving towards the right or towards the left. It is happening with respect to the z-axis, and this is called the yawing axis. So yaw motion will happen with respect to the yawing axis. So these things I have to explain one by one. So here we can see the principles of the flight control system, and just now I have explained that to have any motion we need 6 degrees of freedom. It is called 6 degrees of freedom. This degree of freedom, first we have to understand, then only we can say that the aircraft is having all the 6 degrees of motion or degree of freedom. If you take your cycle, your vehicle or your truck or any shipborne or anything, these vehicles, they are not in 6 degrees of freedom. But aircraft, it has got the 6 degrees of freedom as it is shown in this diagram. This you can see it is a x-axis, this you can say it is a y-axis, and this is you can say as a z-axis. So this x-axis is also called the roll axis. This is also called as a pitch axis, and this is also called as a yaw axis. Okay, so these are the three axes. So if the motion is in the linear motion, it can go towards the x like this. This is the linear motion in x, this is the linear motion in y, and this is linear motion in z. Here it is shown upward z is positive, forward is x is positive, and towards the right side y is positive. So these things we have to understand. And also, so we have got the 3 linear motion as I have explained you in x, y and z direction, x, y and z direction. Okay. Now remaining 3 are rotations. rotational motion. And this how these rotational motions are achieved. These things I am going to discuss in this lecture. So this you can see that if aircraft is pitching nose up or the nose down with respect to the y-axis. So if you see here, this is your y-axis and this x will go either this or this. This is the nose down and this is called the nose up. Okay, so nose up and nose. But how you achieve this nose up and the nose down? If I want to make nose up, there is a horizontal tail. In horizontal tail, you can see there is a black color. This black color strip is a movable strip and this is called elevator. This elevator is operated by the help of pilot's stick. He got this type of stick or he can move like this forward or the. If you want to nose down, he has to put the stick forward. If you want to make the nose up, he has to make the stick upward. So like this, if you want nose down like this, okay, just I am showing here. So if I want to make aircraft nose down, I have to put down. So what will happen here? I need a force here which is acting upward. This force from where I will get? I have to deflect this elevator downwards. So if I deflect elevators like this you can see here like this. So here angle of attack and the camber of this horizontal tail is increased and additional lift will be generated here, and this lift, because CG is here, this will try to make nose down. So if you want to make aircraft nose down, pilot has to apply the forward motion of this stick. The elevator will go down. This down motion of elevator will produce upward force and this will try to make aircraft nose down. So that is the basic principle of the pitching control. If I want to make yawing, if I want to make yaw towards the right, so what I have to do? I need a force here which can work towards the left. Because CG is here, so this CD and force into this moment, it will generate towards the right. So I need a force here. So what I have to do? This you can see here. I think it is visible here. This is the radar. This radar has to move towards the nose. If I want right, it has to move towards the right. So what will happen? A opposite force in this direction will generate and this will pull like this and your aircraft will move like this. And if I want to make nose left, this radar has to move towards the left. A force in this direction, it will be generated and aircraft will move like this. I think it is very much clear how this pitching up and the pitching down is taking place. Now I will go for the next rotary motion. It is called the rolling motion. So this rolling motion, how we can get this? We can see here that if aircraft is flying like this, I want to make right wing down. Then what I have to do? The right wing I need a less lift, the left wing I need a more lift. This is the more, and here we need only this much. Only this much, and here I want this much. So how I will get? This you can see here, ailerons. These are the ailerons. And here at the root, you have the flaps. Ailerons are at the tip because from here, force into distance, a maximum distance should be there so that we can use a small size of the flaps or ailerons. So we need a far away from the center of gravity, this ailerons. Now if you see that I want to make rolling right wing down, then I need to generate a high forces or high lift in the left wing and low force in this. So we know that if you want to make the high lift, the angle of attack, it should be positive and it should go down. So the left aileron will go down like this, who will go down. So it will generate more lift, but right wing aileron will go up, it will reduce the lift. So a net result will be turning this rolling towards the right, and same vice versa. Ailerons will move always opposite. If one will go up, another will go down the same amount. So it is a net lift is same, but one side lift is high and another side is same, but at the center you have the same lift. So aircraft will sustain in that condition. Otherwise, if it is not in the same ratio, aircraft will be unbalanced. So that is why we have to make sure that aircraft is balanced also, aircraft is stable also, and all the control motions are done. I think it is now clear. So I will go with the flight control system, and just now I have explained about the flight control system, and here we have the primary flight control, that is the roll, pitch and yaw. And just now if you see here, and the secondary flight control, high lift control, flaperons, slats and speed brakes. I will explain these all things. Just you can see here, this is the stick, this is used by the pilot, and I told you if you want nose down, this stick has to go in this direction. Pilot has to push like this. So what will happen? This elevators here will go down and a net lift will be acting. This lift of tail into this CG. Assume this is the CG. So this is here the CG. So this is XT. So this LT into XT, this much moment will act in this direction. So your nose will go down. Okay. And if you want to make up, then what will happen? This force will be in this direction. XT will be same. So this LT prime I am writing, it is downwards. This will go minus LT into XT, and this will be in this direction. So like this, we have to see that your things are working. Here, if you can see this yellow color is a rudder. Okay, so here, this is the rudder, and the rudder is to give the yaw. Yaw means nose going up, right or the left. So what we have to do? Just now, pilot has to press the rudder pedal. These are the rudder pedal here. They are called the rudder pedal. They are operated by the feet, by the pilot. So if the pilot is pressing this one, it means he wants that nose should go towards the right. So right pedal he will press. So what will happen? This will move towards the right. Rudder will move toward the right, and this force will be generated toward the left, and this yaw will be in this direction. And if you want left side, then he has to press this left one. This one he has to press, and this yellow color rudder will come towards this direction, and force will act in this direction. Okay, it is a Y force, side force will act in this direction, and your nose will go towards the left, and this is the right. Okay, this is the principle of the rudder, and this is the principle of your. Now these things are, if you want the rolling, then these are the ailerons. Left aileron and the right aileron. These ailerons are moving. Okay, these ailerons will move opposite direction, and if you want that this should go up or this should go down, so the up one will go down like this, and this will go up like this. Okay, so like this things will happen. Okay, now I will talk about the secondary flight control. Here we have the high lift control, flaperons and the slats, and we have the speed brakes. So this you can see that wing flaperon. Flaperons means flap and aileron. So here it is acting as a flap also, and it is acting as a aileron. All the modern aircrafts are having like this, and this is called the speed brakes. It reduces the speed and also spoil the lift also. and high lift. And here if you see, this is the leading edge slat, and this will generate additional area, and this area will give the your another more lift it will produce. So these are the few secondary control, primary and secondary flight control. So here we can see that electrical control, we have the elevator, aileron, roll spoilers, tail plane, trim, slats and flaps, speed brake, lift dampers and trims. These are the, you see aileron is here, flaps are here, these are the slats at the leading edge. If you see here, speed breakers are here, roll spoilers are here, lift dampers are there, lift dampers are to spoil the lift or reduce the lift during landing, or if you want to come down, that time lift dampers are used. Trimming tail plane, this is the trimming, we can trim this tail plane. We have the elevator, we have the rudder, and we have mechanical control, we have the rudder, tail plane and trim. These things are the mechanical, and this hydraulic actuation of all surfaces. So this all surfaces are hydraulically actuated. However, the rudder and tail planes we can make by the mechanical operation also. Now I will discuss about control surfaces, principle of operation. Actually this I have explained just now. This is the center of gravity of the aircraft, and here at the tail we are putting one control surfaces. It is called the elevator. This elevator, if you want nose down, what I have to do? I have to make this elevator like this, downward. So it will generate this lift force, and this lift force into this distance will generate a nose down motion. Like this, if you see here, it is the fuselage and this is the wing. Here we have the ailerons and these are the flaps. Okay, so why we use at the tail, at the tip, this is called the tip of the wing and this is called the root of the wing. So why we use aileron at the tip? Because if you see here the distance, this is the x distance and this is the small x from here. If you take the same lift here and here, here the moment will be less because this L into x, the moment it will be m1, m2 will be L into capital X. So this L into capital X is greater than L into a small x. That is why we use the aileron at that very far away. Same way we use the elevator also very far away. It is the center of gravity. We are using very long distance at the tail. If you see here, ailerons are used at the tip of the wing, both sides. You see here, elevators are at the tail, extreme tail we are putting. So we will get a more distance. The distance arm of this thing will be very high. So a less area of this surface is required. Same thing for this vertical tail and the rudder also. We have very long distance from the center of gravity. Center of gravity will fall nearly here. So this into this distance is important. That is why we are putting very far away from the center of gravity so that the size of the control surfaces can be reduced. That is the objective of keeping any control surfaces which is away from the center of gravity. Now I will discuss about this some work of high lift devices, some simulated results, how these things are working. So here we can see that if it is first case, it is only wings, aerofoil is here. But if you see that another case, we have here spoiler, this two surfaces are here. And if you see the flow distribution is totally different between this and this. If you see here, the y by c means it is a vertical distance and this is the horizontal distance. And if you see here and here, lot of, it is very high pressure here, high pressure, and here is low pressure. If you see upper side, from stagnation point. Here is stagnation point. From this stagnation point to up to end, you see this much area is very low pressure, very low pressure. Comparing to here, it is only up to here. So lot of effective area is increased and upper and the lower side, and very high lift is produced. As we can see in this results, that is why we use the different types of flaps, different of surfaces, so that the net result which we get is quietly good, which we can use for our purpose. Now I will talk about the types of control system, and we can see that here we have the mechanical control, that is called flight linkage system, electromechanical control using hydraulic actuator, fly-by-wire, and these things I am going to discuss in today's class. So here we have the mechanical linkage. It is also called the push-pull rod. If you see here, these are the ailerons. These are here we have the elevator and the tail plane, and here is the rudder we have, and these all are operated here by the pilot by these sticks, and these are the pedal. In this pedal, if you want to move or yaw, these pedals are pressed, and if you want nose up, nose down, this has to go forward, and if you want to roll, it has to go in this direction, sidewise direction. Accordingly, this control, and these all are operated by the push-pull rod, and they are the mechanical linkages by help of the push and pull, and some levers, bell crank levers are there, and they are operating this. This is old type of systems. However, this is still used for some of the trainer aircraft, very light, low speed aircraft. These all parameters, all the things are used. Further, if you see, the detailed mechanical control linkages are there, and here if you see lot of wires, pulleys, these are the wires, these are the pulleys, different pulleys, here also one pulley is there. So different number of pulleys, number of wires, number of rods, so many things are used. So a flight control system is very complex and very complicated, and it needs a lot of expertise to fabricate and to do the testing of the systems. Now I will talk about the flight control actuation. So what is the meaning of actuation? So we should understand that when pilot is moving, your control surfaces also to move. But you know that as the aircraft speed is increasing, the amount of force which is acting on the control surfaces like elevator, rudder or the ailerons is very huge. Like flap is very big. A pilot cannot handle by its own force. A human force is not that much sufficient to handle tons of aerodynamic forces which are acting on the control surfaces. So now they have made some this hydraulic system, pneumatic system, electrical system, and electromechanical system, electro-pneumatic systems. By help of these things, by the motor or by the things, your control surfaces are moving. So the equipment which is used to move the control surfaces is called the actuation systems. So here we have the flight control actuation is important. Evaluation is in ascending orders are given here. Conventional linear actuation, it is very old one. Then mechanical actuation with simple electromechanical features. Multiple redundant electromechanical actuation. So in these things I am going to discuss in this further slides. If you see here, I am talking about conventional actuation. So in this signaling by means of mechanical links, so we use the links rods to signal the system. Actuation by hydraulic power. Important aspects of this system is powered by a single channel. In case of critical functionality, dual channel, mechanical operated servo valve, mechanical actuation can accept a dual redundant system. So in this we can see that it is signal by means of the mechanical links. So this you can see here, it is a mechanical signal. It means rod. It is rod pilot is putting up and down, left or right. This will go to the summing link. From here it will open this green channel and the blue channel. This is hydraulic channels. The hydraulic power is coming from here. This valve will operate. Due to this valve opening and closing, the fluid will enter from this side or moving to this side, or sometimes it will open this side and it will go like this. This is the piston here and this will move. This will move as per the direction of this valve opening. Either it will go this side or this side. So if you take, this is the wing. If I am making one, this is your aileron. Here it is hinged. So here what will happen? I will fix this end here. In this end here and one is here. So it will move and it will go like this or like this. Okay. As per the rotation of this, the aileron, flaps, rudder, elevator, all will move. So this type of system is called the conventional actuation, and it is from very long age this type of systems are used. After that, the next generation came, and that is the mechanical actuation with electrical signaling. So in that, pilot need not to move the stick. It has to press the stick. There is an electrical switch. He has to or she has to press that switch. Accordingly, your actuation will be there and your system will move. So signaling by electrical means, actuation through hydraulic power. Pilot input is similar to conventional control. The addition here is autopilot signal. Here we are putting the autopilot signal. This is the new thing. Previously it was only the pilot, but now autopilot is also there. So pilot can select whether he want to fly or she want to fly, or it can give the input to the pilot. It will select the computer and the computer will act accordingly. We have hydraulic power. In this we have the channels, green channels, mechanical signaling. Then it is a shut off valve here, and this valve will selector valve, and this selector valve will either close or another will open. Accordingly, the fluid will enter in this piston and the cylinder, and this motion of this actuator may be as per the given signal. So this is the electromechanical actuator. Nowadays we use like that systems. Now mechanical actuation with electrical signal, how this thing processed. I have shown you that here we have the two types of signal. One is the autopilot signal, another is the pilot signal. If you talk about this pilot signal, then it goes to the mechanical signaling, then movement of the summing link for actuation. For the autopilot input, it will go to electronic servo valve control unit. Then mechanical signal, it is same, and movement of the summing link and the actuation. This you can see here that here is this summing link has to move by this. So it is moving, and then this part will also move. So that is the function of this type of system. So this I have shown here the flow diagram. This flow diagram depicts that how the pilot input will transform to the net movement of the summing link. Same way, if it is autopilot system, then it will go to the electronic servo valve control, then it will go to the mechanical signaling. This will move a shaft or a link as per the requirement, and the movement of the summing link of the actuation will take place, and this will move all the control surfaces where these things are attached. Now we can see that multiple redundant actuation. Till now I have explained about two types of system, both are the single redundant. Means if it is failed means it will not work. But multiple means if one is failed, another has to work. So it is a double or triple or fourth different types of redundancy is applied. Here we can see the electrical signaling like this. Hydraulic power is given like this and hydraulic signaling is given like this. Adapted for the sake of fly-by-wire system. Like this we use for the fly-by-wire system. What is the benefit? Reduced weight, improved performance, increased passenger crew comfort. Concorde was the pioneer. First aircraft was used in the Concorde, and this Concorde was a very high speed aircraft for the passenger, and there it was used first. Here if you see here, this is the hydraulic one and hydraulic tube, hydraulic power of the aircraft. It will go to SOL, then it will go to the servo valve. From here it will go to the control valve, then it will go to the actuator. Servo valve operations and ram position feedback. This feedback is also means how much position it has shifted. This pilot has to know. Pilot has to know how much it is shifted. Okay, that is the objective of this system. Okay. So now I will go to the advanced actuation technique. In this we have the direct drive actuation. It is called DDA. Use electrical signal for actuation. Another one is the fly-by-wire actuation. In fly-by-wire we see that electro-hydrostatic actuation is done and electromechanical actuation EMA or EHA is done. Electrical signal that pass through some control laws, efficient control of the flight control system can be done. Now I will talk about the fly-by-wire actuation, and it has saved tremendous amount of hard work which is put by the pilot during the flight. Fly-by-wire has revolutionized the system, and it has made the flight of the aircraft is very comfortable and very safe and very good parameters. So here we have the three modes: full FBW modes, direct electrical link modes, and mechanical reversion mode. So if it is a mechanical reversion mode, only pilot can handle. But if you make the full modes, only autopilot will work. And direct electrical link, it is a between autopilot, full autopilot and the mechanical. Actuator control electronics are used for this purpose. This you can see the hydraulic power here. Here is the pilot. Pilot will give command to the FBW. Autopilot is here. Direct electrical link is there. This will go to the actuator control electronics ACE. From here if you see the hydraulic power will come to this actuator, and it is called the hydraulic jack. Okay, this jack will be operated by this valve, and LVDT, it will measure how much it is transferred, how much distance it has traveled. This equipment will queue, and accordingly it will react and it will further supply, and this feedback is maintained. So like this, a system of fly-by-wire is working, and it can work as a manual with the help of pilot, and another it can work as a autopilot as per the requirement. Next we have the electromechanical actuator, similar to EHA. EHA is what? EHA is electro-hydraulic actuator. Here it is EHA. So now similar to EHA, only difference is the electrical signals are replaced by a motor. So here if you see here, fly-by-wire and direct electrical link, it will go to the ACE. From here the three-phase AC signal will come to the power drive of the motor. Then a electric motor will operate. This in place of, in this hydraulic is not there. This motor will move with a screw jack. It will move either this side or this direction with the help of the reduction gear. and this RVDT, it will give the rotation of this thing and it will give feedback to ACE, that is electronic control unit, and from here again it will be rectified and appropriate signal will be given electromechanical actuator. So this is the electromechanical actuator. Okay, so in this way the systems are working. Now third one is the electro-hydraulic actuator. In this, power electronics and control laws for efficient operation. Conventional system imposed continuous pressurization. EHA draws the required amount as per the demand. Three-phase AC power to power drive electronics. Okay, so this is the systems, and fly-by-wire, AC, direct electrical, three-phase AC electrical power drive. Here we have the variable speed motor. In there it is not there. Fixed displacement hydraulic pump. Here we have hydraulic pump also because it is electro-hydraulic. If you see the previous one, in this only this power drive and motor is there. But here if you see, we have the power drive, we have the speed motor, variable speed motor, as well as a hydraulic pump here. So both are working. So it is more redundant, more safe. It can work better than the previous one. These are the references which I have taken from the Moyer and the Seabridge aircraft systems, mechanical, electrical and avionics system. Another one is design and development of aircraft systems and introduction. This is my second book. Any questions you are welcome to ask. I will be very happy to reply you in this email. You are welcome to ask, and also I request you to like and subscribe this channel. Thank you very much for joining this my lecture. Please be tuned for my next lecture. I am going to discuss few more lectures on this aircraft systems. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.